Hello, hello. We are back. Perfect. Stream is live.
Please submit the challenge you would like to see solved on stream first to the Stream Q&A channel in Discord.
Scope Twitter accounts? I'm not sure what you mean by that, Zuda World. If you can specify, I can probably answer it. The old recon accounts that I had? It was a lot of just garbage. So, give me a minute. I'm going to fix the lighting. Way better. Alright, OSINT 8. We're going to cover all the OSINT challenges. Alright, it is 7:10, so we're going to go to a welcome speech. So, hello. Thank you for being here. Thank you for coming and watching. I want to, first of all, say thank you to everybody for participating and to everyone who helped make this event possible. It took hundreds of work hours, so to probably thousands. So to everyone who participated, I hope you enjoyed. To the developers, this has been awesome. You guys put in so much work. You all put in work, time, effort, and passion into this event. It's great. To the people who did our art, thank you so much. Your creativity has been really invaluable. And then, to the people who, I want to call out a few people specifically. To Thing79 and White Hood Hacker for handling almost all of our tickets and fielding them to the relevant people. You are awesome, and you saved so many people so many headaches from trying to figure out who is for what. You guys are wonderful. Thank you very much. To Anusha and Ian for taking the graveyard shift both nights with me till, 5, 6 in the morning. I would have been very lonely without that, so I really appreciate you both doing that. To Ankur and kuilin for being absolute infra legends, and to Daniel for getting us the GCP credit, so we didn't have to pay for our infra. Thank you all. And thank you anyone else who I have neglected to mention. To all the alumni for submitting challenges and helping run the event. To anyone who's not from University of Illinois, but wanted to submit challenges or just help run the event. Thank you. Let's talk about jobs.
Hi everyone. My name is Ian Glasgow. I am a former president of SIGPwny. I am currently employed by one of the 3 security consulting firms that you see on your screen right now, and they gave us prize money, which means that if we get somebody hired, they'll give us more prize money in the future. So, if you are interested in learning how to get a job in security consulting, or if you are interested in security jobs in general, please send me a direct message on Discord, and I will happily do things like look at your resume, offer feedback on it if you'd like, tell you what kinds of security companies do different kinds of work, and maybe even put you in touch directly with somebody who is hiring at one of these companies. Feel free to do this anytime. My DMs are open.
All right, and again, thank you so much to our sponsors. Thank you for helping make this event possible. I should really go back here. This wouldn't have been possible at all without our sponsors. So Red Lattice, Leviathan, NCC Group, the other sponsors who we have on our website, Red2 Systems, Google Cloud. You're awesome. Thank you. So, event statistics. These were taken, I believe these were taken at like 6:30, but nothing has changed since then. So there were 64 challenges, and 61 of them were like non-meta challenges. There was the welcome to Discord, and welcome to the event, join the Discord, and the survey, which were meta. So we had 61 actual non-meta challenges, which is the most challenges we've ever had at UIUCTF, which is awesome. The most solved non-meta challenge was Wasm Baby, followed shortly after that by, I want to say, PHP, and then one of the OSINT challenges, I believe. The least solved challenge with greater than 0 solves is Ropfuscated, which is really cool, and we would like to see that solution method. So if you are the people who solved it, please reach out to us with that solution method. It would be appreciated. We had just about 1,900 users registered and just about 1,000 teams from 5,100 IP addresses. So, then here's some more fun statistics. The solve rate was about 56% of the flags were correct. Here's the breakdown. Then two things that I grabbed. There were 480 responses from the charliechaplin.dev contact form. And I received, the charliechaplin.dev Gmail account received 154 emails. So I also received lots of requests on LinkedIn for that account, and many of you tried to reset the passwords to those accounts, which was out of scope, but very amusing to receive those emails. So, all right, we are ahead of schedule, and the scoreboard's not in. Is that edited? And if I go back, yes, it is. So if I go back to present, oh, here's the top 10 leaderboard for the auction bot. So SIGPwny, wow, that's a lot. SIGPwny, they broke Isabel bot last year, so that was funny to see them break the bot this year as well. So here's the final scoreboard. We've got in first place Super Guesser with a score of 10,995. Second place is Hoax with 9227. Third place is IrisSec with a score of 8,430. Fourth through 10th place, ECSC Team France. Congratulations. Mountain, good job. Wreck the Line. Ohm, the Hackers Crew, Black Bahiana. Wow, I butchered that. Apologies. And 0 points for 4th through 10th place. And then for 11th through 15th place, it's Cat But Sad, Teamless CTF, Magnum, I Don't Even Know, and Breakpoint. Congratulations to all the teams who won prizes, and more importantly, congratulations to everybody for playing and learning something. The real winners were all of you, because hopefully you learned something from this event. That's a huge part of why we run these, for you to have fun and for you to learn things. All right, so that concludes the scoreboard. Let's go to challenges. That was ridiculous, but also funny. Let's talk about challenges. So if you're going to drop what challenge you'd like in the Twitch chat, or if you want to drop it in the Q&A, we will echo those things in. There's no exclamation point request, just say what challenge you would like. So, All right, SVG.
I guess we can open up with Pwnies Please, I guess.
Pwnies Please.
Yeah, that might be a nice one.
All right, so that's...
I think the best approach here is probably going to be you navigate to the challenge in your web browser, and I explain to you how to solve it, and you click around in the UI. And then that way we get kind of the learning.
All right.
So we're going to start with Pwnies Please.
Where is Pwnies Please? Web or MISC?
Control F is your friend.
Good point.
You'll notice that the challenge description says, disguise these ponies to get the flags. Congratulations to Zhuyifei2001 for solving this first and winning the $100 bounty. I still need to double check the solution, but I'm pretty sure that they got it. Go ahead and give that a click. This is an adversarial machine learning challenge. You can see that at the top it says, welcome to the Pony Club. Here's the pony. You need to sneak them past the bouncer. Can you give them a costume to wear? Make sure you don't overdo it, or the bouncer will see right through it. So this is hinting a little bit at the architecture of the challenge, which you can see at the site source code at the very bottom. But the first thing that you should notice is that you have received from the web server a photo of a pony that is very low resolution, and you have the ability to upload and get, there's an integer number of horses that you've snuck into the club. So this is emulating a couple different CTF challenges that are very much of the same genre that have been run in different CTFs, with a little bit of a slightly unique twist in that it is attempting to fool a non-robust model. Let's take a look at the site source code. The last line right there.
Yep.
So scrolling through, you'll notice that it's pretty long. The code is a little spaghetti. We were working on it very hard. But there are a couple of things to point out. Could you zoom the window a little bit so that we get a little bit cleaner text? Just Control plus. Control plus it. So you'll notice that at the very top of the file, it is loading a data set and the models. You'll notice that there's a model robust and a model non-robust. So that's the sort of the first thing that I would notice if I were reading the source code of this challenge. You'll notice that there's a function for generating an image that just pulls it from the data set. Go ahead and keep scrolling. There's a couple utility functions. The one at the bottom is tensor to image, image to tensor, bytes to image. These are all just different functions for manipulating the image, which we've provided for the convenience of users, but also so that we could make the challenge solvable. You'll notice an unused getPrediction function, which is immediately above another getPrediction function. These do roughly the same thing at a high level. The one that we ended up using is our original approach, which is using a library called ImageHash to compute how different an image is from the one that was originally sent to the user. You'll notice that there's also a loving comment that says where the magic happens, thanks to an auction voice call uttering. Go ahead and keep scrolling down. Feel free to ask clarifying questions in the stream Q&A, by the way. This is the main routing part of the web application. So this is simply the part that takes requests from the user, and you'll notice that there is a post handler which takes images that have been uploaded. The images are constrained to a size of 224 by 224. The image that is served by the server is also 224 by 224. You can see a block of 4 comments that describe a forking bit of logic. And so this is the core of the challenge. We want to get to the point where it says flag. The robust model should say horse, and the non-robust model should say anything other than horse. So the challenge is loading a machine learning image classifier, and it is attempting to classify the image that you upload. There is a robust model that Anusha trained to make to be slightly difficult to defeat. And then there's a non-robust model, which is comparatively easier to defeat. So our goal here is to make them disagree. So we need to modify the image that we were served and add some amount of noise such that it is misclassified by the non-robust model, and it is still classified by the robust model as a horse. So the non-robust model is our bouncer that we're trying to defeat. If you scroll a little bit further, you'll notice at the bottom it says session YOLO plus equals 1. And immediately below that, there's also a session level plus equals 1.
Yep.
So these two variables serve a purpose of attempting to block just completely random noise, and the level is once it maxes out at level 50, that returns the flag. So the intended solution for this challenge, since we provide the model, is to load the model, take the image handed to you by the web server, and modify it until the model no longer thinks it's a pony. So you want to modify it as little as possible. Once you've done this 50 times, you pass the CAPTCHA, basically. This is effectively a pony CAPTCHA, by tricking the non-robust model enough, which is intended to be automated, and then it returns you the flag. So that's the process for solving this one. Anusha, did you have anything that you wanted to say?
Not particularly. This was a really fun challenge to develop, and shout out to everyone who kind of helped me kind of from genesis to completion. It was a really fun time, and I hope you all had fun solving it.
There were over, I think, 7 people who ended up touching the code for this ultimately, between training the model and deploying it and designing the architecture of the challenge, which was a lot of fun to do. We have a question from Zuda World in the Twitch chat, which is, does the image have to be modified 50 times, or does it need to be 50 different images? It is 50 different images. You must receive a pony from the server, you must modify it until it is disguised by adding some amount of noise or training it using the model, and then send it back, and then the server will send you a new one. There's a cookie, a session token in a cookie, that tracks the state of how many you've solved so far. And so basically, after you solve 1, your number, you've gotten 0 horses into the club, goes up to 1, and you want to get this number to 50.
All right. Does anyone have any more questions about Pwnies, please?
Oh no.
Anusha, if you have anything you wanted to say, after that I think we should move on to the next challenge.
Yeah, sounds good. All right. Let's go to the next challenges. All right.
I think we said we were going to do OSINT next. I would say maybe let's do quickly a couple of them, and then let's hop to another audience request after we've solved one of the OSINTs.
Sounds good. What OSINT of all of these OSINTs would you like to see completed? Just, I'll give about 20 seconds for people to spam in chat or the Q&A. OSINT 8.
We have a request for 6 through 8. I think that's probably a good set of them to do.
Let's do 6 through 8. All right, so...
Thank you, Cool Guy IOI, for the suggestion, and also Mine I3 Out.
All right, so... Is it... I think it's... Okay, so 6 is LinkedIn. There it is. So you start, for number 6, you start on the LinkedIn page. And that is bright and changing my camera exposure. It doesn't matter. So you start on the LinkedIn page. Now we've got several interesting things here. We've got an event that's going on right now, from now until when it just, for a week. Then we've got an event that just very recently closed on August 1st. And then we've got that 44 people are attending. You might want to remove that from your profiles. And then we've got a post here that says, had a great time with an event that I ran 3 days ago. I hoped everyone liked their top hats. Now that's not necessarily enough information. So if you go to see all activity, we've got, I'm hosting King Cannon Night. Had a great time with an event that I ran a few days ago. I'm hosting an event. Would anyone like to attend? So that's not too much information, but we can start there. And if we search up top hat, I feel like there's a post missing. Is there a post missing? I was at some point I was at some point very clear that there was an event here. Yeah, that's fine. So if we go to events and Top Hat, there's something called Top Hat Development Night. And if we open the image in a new tab, looks like Charlie Chaplin. So if we click on this, Top Hat Development Night, develop while in a top hat. Then we've got develop while in a top hat. We invite all of you to participate. Winners will get nothing. Losers will also get nothing. And one last thing. This is a professional business environment. And there's the flag. So that was OSINT 6. And then OSINT 7 is on GitHub. And there wasn't actually a direct link to GitHub from LinkedIn, I believe. Unless there was. And if there was, then that makes it a little bit easier. But the trick here was to search up the same general string here. Because we have Charlie Chaplin dev. And on the LinkedIn page, it was Charlie Chaplin .dev. Or Charlie-Chaplin-dev. Charlie-Chaplin-dev. So if you concatenate all of those things into a single word, it's Charlie Chaplin dev. Let's take a look at the repositories. So we've got the About Me repository, which is just hello. And then right here, we've got the C3D, which is Charlie Chaplin Coding and Development official code repository. Now there's a lot of things going on here. There's a file. Did anyone try to do decryption on this file? Yes? No? I'm gonna hope not, because this was just a random file that I generated. Same with code.c, butts.py, because, I don't know, the readme, and then the license. Now, if we look at the commit history, we can see secret keys, an RSA private key. Uh-oh, that's not good. And then, okay, phew, resolved issue 3. And if we go here, secret key, this is bad, key, bad, company release key, bad, what do I do? And then that's the true PR nightmare. That was what Charlie's PR nightmare actually was. So, that was the solution to number 7. And now let's move on to number 8. So, for number 8, if we go into the commit history, we can find out what the email is. There's probably a lot of other ways to do it, but here is a way to find the email in plain text. So if we go to createsecurity.txt, there's a comment by a person. If this computer has a vulnerability, email me at this link. Please thank. Or at that email. Please thank. So the actual method here, and I don't know if it's totally set up, and I don't know if I want to go to my personal email, because you'd have to do that. I will explain the method verbally, and then we can go to write-up. You can look at write-ups when they are publicized. So the actual verbal method is you sign in from another email account, and then you can add it to the contacts. You can do something, but you want to interact with that email. From there, once it's in your contacts, you can call some Google API to get the user ID, and then from there you can get the OID, which you can then take and so here's the OID. That is not the person that I thought it was going to be. Whoops. These are different reviews. Charlie Chaplin. There we go. So we've got Charlie Chaplin, and we've got one contribution, and we go to the contribution. You can see that it's a photo, and it's from Montrose Beach in Chicago, Illinois, the dog park. And if we click on that, we've got Bork, Bork, I love my dog. So That is the solution to OSINT Challenge 8.
Alrighty. I think the next one we're going to do is insecure Seccomp.
All right.
Who wanted to take that? Yifei or Ralphie or...
I'll take it, because it's mine.
Brad, let's, should we have Thomas pull up any files, or...
Pull up the challenge description, pull up the zip, tarball from the download.
Okay. Do I need to do things with the tarball?
Open it. I'll show the file to explain what's going on in there.
Okay. Give me a minute. I need to make I need to make a folder. Give me a minute.
Could you pull up the insecure Seccomp description while you do that?
Yep. Is that web? Control F. All right. Okay. All right, Yifei, whenever you're ready.
Okay. I cannot see it on your screen. Say archive.
Yeah, you need it? Okay. Do you need me to unzip it or keep it as it is?
Can you show the file is inside? It's specifically I need the source int.
Okay, so you need
SRC.
Is it XZDF?
XZVF should work. Handout.tar.gz. You need the full file name.
It's
Wait,
there.
Why do you have a second? Just without the second.
Oh, got it.
Just the file name.
Okay.
Alright. Going to source int. Source int.
I know.
SRC int.
Int?
INIT. It's a file.
Okay.
Okay. So in this challenge, the flag is under the root directory. There's a read-only file for root. I mean, not read-only, root-only file called flag. And there's one path to escalate to the root privileges as the exploit.me in the user local bin. Can you show the source code of exploit.me? There should be a file called exploit.me.c here. So this one tries to see if it can read flag or not, and then it performs a set UID to root. Set UID by its current EUID, and then it executes a shell. So this is set UID program. If it sets UIDs set UID successfully. So when it has the set UID bit in the chmod true. So when it runs if you don't use say strace or any ptracing methods, it would escalate its effective UID to root. So get EUID should automatically return 0. So set UID get EUID should set its real UID and its effective UID both to root. So what happens here is that if it runs there, it would exec some root shell. However, the problem you have is that it would check if flag is readable by its current effective UID. So the trick here is to use Seccomp to trick it to think it cannot access the flag. So if you open the Seccomp loader.sysc.
Yep. It's open.
Okay, so Seccomp loader.c It's I made it easier so you don't have to put the executable inside. You can just put the Seccomp Seccomp filter in hexadecimal through this program. It will load it for you. The filter is check if the syscall number is same as the FX access at syscall, and if it is the syscall, you would reject the syscall as it's not being accessible, and then afterwards, if it's not accessible, the exploit.me would pass that check of it cannot read flag, so it's safe to run. It escalates to root, and now you have a root shell.
Wow.
I've seen other people who attempted the challenge by faking the set get UID to 0. That is not the method, because if effective UID is not actually truly 0 in the kernel, like if you're only faking it, then your set UID attempt would fail, because set UID will only allow you to set one of like a UID that's either your save UID, the effective, or your real UID. So the effective has to be 0, truly 0, in the first place. Yeah. So that's my explanation. Any questions?
We'll give chat about 1 or 2 minutes to ask questions, and then we can keep doing other challenges that people are requesting, or we can move on to whatever was next on the schedule.
Oh, I think I should clarify. This attack does not work in the real world, because in the real world, if you want to load the Seccomp filter, you would have to set the no new perf. So set UID would not work at all. So after you load the Seccomp filter, there's no path to escalate. There's a kernel patch in here that in the handout in the kernel directory, it's disables the check for no new perps.
Got it. Thank you. And thank you again, Yifei, for making this challenge.
Oh, introduce myself. I'm Yifei. I play with kernel. Yeah.
Okay.
Plays with kernel just a little bit.
Just a little
Just a
bit.
little bit. Just a little bit. Yeah.
Yifei works with Linux kernel very much and has commits in Linux kernel, which I think is super cool because I don't know how to do that. But Yifei answers all of my questions, which is great. Thomas, I have an idea for a workflow that I think would be good.
Yep.
Let's have you SSH into one of our development servers, and everyone else from SIGPwny will also SSH in and be able to work in a tmux that renders on your screen.
Okay, that sounds like a great workflow.
Please give me a pub key. Please make sure it's not the priv key.
Yep. I did break for stream. Oh, that's my personal technical difficulties thing. All right, we're just gonna do that. Okay. 1 second. There you go. And then let me know what to SSH into.
It's right there.
Okay.
And we're going to pull the terminal back up in just a sec.
Yep.
What challenge should we do next? Could y'all chat in the stream Q&A or the Twitch chat, please?
I'm gonna make a tmux. How do you name the sessions?
New tmux new dash s pony.
Thank you. Normally I just type tmux. All right, and we're gonna switch back to stuff. Let me know if that is too small or too big.
That looks perfect. Maybe let's find out. Let's generate some tmux a.
Oh, people are here. All right, people are here.
Alrighty.
So, which
What
challenge
should we
is-
do next?
Well, on the schedule was Pwn Warmup.
Pwn Warmup?
Yeah. So we can do.
We have a request for miniature horse DB. KMH, would you be interested in walking through miniature horse DB?
Yeah.
Are you SSH'd into the server? If not, can you throw me a pub key?
I will send one. Yeah.
Alrighty, Thomas, if you could pull up the child description for miniature horse DB, that would be great.
Yeah, got it. I don't know if I ever actually introduced myself during the actual event. Hi, I'm Thomas. I'm the current president of SIGPwny. This summer, I'm working at Plant Moran, which is a consultancy that does a lot of accounting and also pen testing. In the past, I've worked at Trail of Bits and just a few other firms. I do research. I go to the University of Illinois, and I do research with the University of Illinois, researching computer networking and security. So that's me. Hello. We're going to do Pwn Warmup, I believe. Or were we going to do Pony DB?
We're going to do miniature horse DB.
Got it.
KMH is SSHing into the server now, and we'll be able to. If you could CD into the deer for miniature horse DB.
Yeah, I don't know what it is, and I don't want to expose internal channel names.
Yeah, no, I can navigate to it now. So yeah, miniature horse DB was actually like a.
Real quick, KMH, introduce yourself.
Yeah, so I am Kevin. I am an incoming freshman at SIGPwny. I've organized like a lot of other CTFs. Angstrom CTF was probably the biggest one. I wrote a challenge for DICE CTF. In middle school, I organized TP CTF, which was awful. So yeah, I've wasted a lot of time on this stuff. But yeah, incoming freshman at UIUC, and yeah. So this is the source code. It's a Flask app, and so this was like a quick fix for PonyDB where I had a typo that made it significantly easier. But the basic idea is you've got like, I don't know, you store a database of ponies, or in this case, miniature horses, and you have an insert thing. Yeah, I mean, I guess a lot of you probably looked at the challenge, so I won't spend too much time kind of summarizing what the setup is. But you can add one, and there are some checks enforced on the data. The name cannot be too long. Biography, like all of them have length limits. And of course, the problem with PonyDB was that I forgot the error equals on this one and this one, so the string was just sitting there doing nothing, and there was like no length limit because of that. And the reason that is helpful is because these are embedded straight into JSON using, like, because I have a JSON column that I parse when displaying the data, and yeah, that means you can kind of like get out of the JSON. Oh, and we should look at what the goal is. How do we get the flag? Let's see. Equals flag. Okay, so we got to look at the template for this. Yeah, if favorite is equal to number, and pony favorite's favorite is equal to 1337, then it displays the flag. So why can't we just set our favorite number to 1337? Well, it's because ponies apparently cannot count higher than 100. So we've got to figure out a way to bypass this. And one idea you might have is to just set this custom favorite field to be number 1337, except the favorite key.lower favorite value comes before the number here. So, and the Python JSON parsing library will just take the last one. So that doesn't work. And like one way to approach this, I guess, then might be to truncate the end. And this is normally not possible with MySQL. Normally it just, like, I don't know, it just cuts you off, kind of. Well, it doesn't even just cut you off. No, it doesn't cut you off. What it does is it just rejects it with an error. However, I overrid MySQL mode to be no /escapes, and it turns out that like, functionality of not truncating but rather throwing an error is due to a specific default MySQL mode setting. And since that has been overridden in order for this, security feature to be present, now MySQL will just silently truncate anything greater than the column width, which in this case is 64 for name and session, 256 for everything else. And we care about the favorites column because that's the JSON one where we're trying to get number out. And so for miniature horse DB, since we're missing the length check here, because I forgot the error equals, here, well, that's not what I meant to do. Okay, yeah, but here, you just throw in a bunch of stuff here, and you add in like double quotes to end the JSON string. You go comma, like double quotes number, double quote, colon 1337, and just pad that to be the 256, after which the word and number get cut off. And you might have to add a word to prevent it from erroring, but now you just have, and of course you need like your quotes here. You just create a valid JSON string, as if you just sliced this to be like up to 256. And as long as that output the valid JSON string with number to 1337, you'll get the flag. The issue is with miniature horse DB, you do have the length check, and the question is like, how do you bypass that? And the answer is there is this dot lower here, and you would think that converting a uppercase letter to lowercase would not do anything. However, let's go in Python, and let's just verify our assumption that len c is equal to len c dot lower. Let's see, let's just get everything where this is not true. So c rc, if when rc is equal to len rc dot lower, if it does not equal. Okay, so we do this for c in range, and what is the maximum Unicode value? Let me check. 0x10 1212. Cool. So we run this. Oops, I messed up where this is. Now, oh, that's concerning. There is a character where that is not the case. So let's look at what happens when we do this. So we have this thing. When this is 1, when this dot lower is 2. Okay. So now what we do is we input, and specifically this is char 304. If we look at the code now, we can do the same attack we did with PwnyDB, except now favorite key.lower and word.lower, we input the maximum length of char 304 for those, and it turns out that is like pretty much just enough to, I'm going to go to solve.py, pretty much just enough. You can see char 304 times 23, char 304 times 64, and that will get it truncated at my number 1337 here. And there you go. There's like that's where it gets truncated, so that this part is just totally left out, and that gets you the flag. And I can run the script, I guess. Or, yeah, I gotta change the... Yeah.
Awesome. Thank you so much, KMH. Does anyone have any questions about Miniature Horse DB? We'll wait like a minute.
Next up, we're going to do probably PHP fuck fixed from arxinex.
Sure. I think it's gonna be kind of hard for me to show you guys the full challenge because I do not have a way to present a web browser to the stream right now.
Ankur, do you want to introduce yourself?
Oh, hi. My name's Ankur. I am a grad of UIUC, a former SIGPwny member, but I'm still very active with the club. I currently work for Leviathan Security with Ian, and I like web and browser bugs.
All right, I have browser here.
Yeah, we can just play SIGPwny plays Thomas solves UIUCTF
SIGPwny SIGPwny plays I solve challenge.
Sure.
You know what? It might be scuffed, but it'll be fun.
Thomas, can you go ahead and pull up PHP fuck fixed on?
Yeah. Where?
It's in the jail category.
Thank you.
Yeah, so go to solution and readme.d.
And readme.d.
Oh, sorry. Can you navigate to the SIGPwny challenge repository on GitHub?
Oh, yeah.
You can show shell.
And also open that in one tab. I mean in a browser. Sorry if that wasn't
in
clear.
a browser?
Yeah.
I think we have a preference for using the shell.
Okay, we can try that. Although the formatting will be hard to view.
Is there a GitHub repo for this?
Yeah, there is.
Okay. Where? Here? Or like the actual internal
Oh,
repo?
sorry. No, like our internal repo.
Oh,
Let's not.
Yeah, let's
Let's
not.
not do that. Yeah, okay.
Yeah.
Fair enough.
I mean, we can do it from here. Can't read me.
Yeah, let's do that.
Can someone expand their window so we see everything? Because right now Tmux is doing the shrink.
Okay, so first idea of PHP fuck was essentially get RCE in PHP using 5 unique characters. And the goal was to read flag.php in the same directory. The flag was there as a PHP comment in the file. I messed it up originally, which was the solution to regular PHP fuck, because I put it in as like an HTML comment or something like that. It was very stupid. But anyways, for PHP fuck fix, the first idea was to figure out the char set, and the one which I came up with was for 5 characters was parentheses 9 XOR and dot. And the reason these characters are useful is because you can construct a lot of different things with them. And there's a lot of different PHP tricks you need to use and abuse in order to solve this challenge. One thing, for example, is you can construct different numbers using XOR. So for example, if you XOR 9 with 99, you can get 106. Another trick you can use is concatenating 2 numbers gives you a string. So that's one way you can generate strings. Another thing you can do is you can use the XOR operator on strings in PHP in order to XOR each character within the string, within the 2 strings, and the output is another string. Another thing you can do with PHP is you can do type juggling things in order to cast the strings back to ints. So using like a combination of all of those tricks, you can get all the digits from 0 to 9 as numbers. But it's still complicated because constructing arbitrary strings requires a little more work. If you want to generate an arbitrary payload, ideally you want to figure out how to call the CHR function. Because the CHR function is just like the CHR function in Python. It'll return a character based on the integer input you pass into it. But the problem is we don't have an easy way to construct characters in the ASCII range, and in order to call the CHR function, we need the string CHR. one trick, if you look at where I am on this line in the markdown, is in PHP, if you put parentheses as like a function call after a string, it actually looks up the function with the same name as that string in a case-insensitive match and calls that function, which is just like absolutely bizarre behavior. I've never seen another language that does this. But it lets you like dynamically call functions based on parameter, I guess. And so in order to get CHR, the first trick we'd use to get something in ASCII range is putting a really long string of 9s. If you put in a really long string of 9s, it resolves to INF, and you can cast the INF to a string. So then once you get INF, you can use XOR tricks in order to eventually get CHR as a string. And once you have that, you can just pass in numbers to it, which again you generate by XORing 9s together and other things. And then you can generate arbitrary characters. And once you get arbitrary characters, the rest of the challenge is pretty straightforward because there was another PHP fuck which existed on GitHub, but it used 7 characters, and you could copy the same approach that they used there once you can generate arbitrary characters. And I think the general idea is just to call create function with the characters you have in your payload, and that will create a function with those characters as the contents, and then you can call that function. So there's this challenge was really tricky. There was a lot of PHP weird shenanigans and behaviors that you had to find and abuse. Don't ask me how I came up with this. I just spent way too long staring at PHP code. And I was looking at the PHP fuck repository, which did it in 7 characters. And I was just thinking about how you could get it shorter. And I realized you could do things like this to get down to 5. So I hope that helped. That's pretty much all I have for the challenge. Let me know in chat if you have any questions.
Next up, we're going to
Alright,
have...
Thank you. I'm sorry.
Next up, we're going to have Vanilla talking about, I think, Smorgasbord and a few others.
Hey, yo, I'm Vanilla. I am an imposter from the University of Washington. Not anymore, at least formerly. Used to be part of Batman's Kitchen, and I was invited to contribute a couple of challenges. So I... Oops. Let's see. So the 3 challenges I contributed were plugin, Smorgasbord, and gatekeeping. So I guess we'll start with gatekeeping. So gatekeeping was a Verilog challenge under MISC. And you receive this Verilog file called synth.v with a module called logic. It is pretty difficult to understand what's going on here. So Verilog defines a hardware module, and it defines a bunch of logic. So you can have like gates in there. You can define other kinds of more complicated logic, but this uses very simple, just gates. When you look at the interface to the module, there is a clock signal, a reset signal, a byte bit vector signal, and a good signal that is out. Everything else is in. You can kind of guess, given the signature, that you need to clock in bytes until good goes high. So how do you do that? Well, this logic in here is pretty difficult to understand on its own, but there is one sort of saving grace here, and that is this module saves state. There is this register called state, which is 27 bits. You might be able to infer, given the problem, that it implements a state machine, and indeed it does. So the intended solution for this was you can take the state variable, export it as another output, and then you can run various inputs through it and snoop on the state. you can imagine that if you output, or if you provide an invalid input character, then the state is going to go back to some invalid state. Whereas if you continue to provide valid input characters, the state is going to continue to change. So you can sort of do this character by character. So like try every character for the first one. How does the state variable change? If it all changes to the same one, that's probably the invalid character. But if it changes to something you've never seen before, then that is the correct character. And you can proceed this way, character by character, to figure out what is the correct character. And eventually you come up with the full flag. And you can write a script to do this for you, or I believe you can also do it all in Verilog, although it's probably easier to write a script to do it for you. Does anyone have any questions on this? I can't actually see the chat, so some other moderator is going to have to tell me.
Yep.
We'll wait. We'll wait for about like 1 or 2 minutes for questions to pile in via the Q&A or via the Twitch chat.
Sure.
Which challenge is next?
Next, I'm going to be talking about Smorgas board.
The CUDA challenge.
The CUDA challenge.
And will you need anything that isn't SSH for this?
No.
Okay, awesome.
One question from Twitch chat. Sarah asks, can we actually solve with symbolic analysis directly?
Probably. I don't know how to do that, but there's probably other solutions, other ways to figure out how you could advance the state or get the good to go high. I was just, when I was trying to come up with a solution for it, I figured sort of the easiest way would be a kind of smart way of doing brute force, like state-informed brute force. But I'm sure there are other ways to do it as well. Yeah, there's probably other ways. Whoever just typed steam locomotive, why? Okay.
Wasn't me.
Well, we can go ahead.
It was me.
What's that? Okay. We could have a steam locomotive if we want.
Then we'd have to install it.
Well, that's fast.
Are you going to move on to CUDA?
I will, but first we need to see a steam locomotive. Okay. So, next, our CUDA challenge. I don't have the binary here, but the first step would be you can use kuobjdump. Well, after you reverse some of the CPU code using standard tools like Redair, IDA,
is it in the repo?
Ghidra, any of those, you can sort of see that the meat of the challenge is in CUDA. It takes an input from the user. It transforms it using a CUDA kernel. It compares the result of the buffer after passing it through the CUDA kernel to a hard-coded byte string. And if it matches, then you have solved it. And if it does not match, it also tells you that you have not solved it. So given that the meat of the challenge is in the CUDA kernel, you need to extract the CUDA kernel. And you can start doing that by using kuobjdump to dump the PTX. PTX is the assembly language that is in common between all NVIDIA GPU architectures. So the PTX gets compiled. So CUDA starts as like C++. NVCC first compiles it down to PTX. PTX can be further compiled down to instructions for individual GPUs, but that's not often done. And the PTX will always be there for forward compatibility for new GPUs that have not been released yet. So you can dump the PTX and you'll get some plain PTX file. I don't actually have kuobjdump on this computer, nor do I have smorga.exe, but you could do that. I guess that's also how you can install it through apt there. But then you can look at this PTX file. So you have some headers. And then we have this encode function. So it takes two parameters here. The first one is a pointer. You can see it is 64 bits. The second one is an int. So most people are probably not familiar with PTX, but fortunately most of the instructions they may be reminiscent of instructions that you would see on the CPU. For example, there's move. I mean, it's a little bit different because it's move.u32. Maybe you don't see .u32 on x86. The registers are named a little bit differently. %R1, %R159. That's also a lot of registers. You don't have that many registers on x86, for example. But you also see similar things like convert S64, S32. That's probably converting a signed 32-bit integer to a signed 64-bit integer. Similarly, like load, you may recognize from RISC architectures. There is one thing that's a little bit different about CUDA code in that.
Hey, Vanilla?
Yes.
Are you talking over specific content? Or are you just... Is there things that should be on the screen?
I am talking about what's on the screen right now, yeah.
Uh-oh.
Huh?
Your screen and our screen are different.
What do you see?
That's odd. I see the Tmux window is fine.
Oh,
so
there it
perhaps
goes. I hit a key.
Ah, great. Oh, we're good.
Okay.
You click the screen, which pauses it on WSL.
Oh, my bad.
Okay. One thing that's a little bit different about CUDA is it has these predicates. So there's setp.ne.s16. So this does a comparison to see if rs1 is not equal to 0, and it sets predicate 1. Then after that, you can have instructions that are predicated on that predicate. Here we have at %p1 bra bb01. So this is a conditional branch, but the condition works a little bit differently in that it doesn't have like condition codes on x86 that are implicit. Instead, it sets specific predicates. One other thing that's a little bit different about CUDA is it is highly parallel. So you have thread IDs. Let's see. I don't know how to select. There we go. So we have here oops. Just a minute.
Sorry, I think somebody touched the binds. You'll have to just wiggle the cursor.
I cannot use the cursor. Here is like tid.x. That is one of the built-in variables for figuring out which thread ID you're on, because this is executed concurrently across all of the cores in your GPU. Well, I'm not going to try to reverse all of this individually, but the gist of it, if you were to try to reverse it, we start by finding the length of the string that was passed in and setting that in a register. Next, there's an unrolled loop where we go along the string, modifying it, multiplying by a constant and doing a modulus by a prime, which is an invertible operation as long as the input is not 0, which it never is. And then we do an addition, also modulo, although we be careful to make sure that the number never goes to 0, which would discard information. There's a lot of repetition here because the compiler unrolled the loop. And then there is a second loop where we do the same thing in reverse. As a result, every byte of the output depends on every byte of the input. Because every single operation here is invertible, you can also invert the entire operation, which you can do to take the string that was embedded in the executable that we compare to, and invert that to figure out the input to the challenge in order to make it succeed. And that is the flag. Unfortunately, the machine we're running this on doesn't have CUDA. Also, it's a Linux machine, not Windows, so I can't show you it running in action, but that's how this one works. Do we have any questions about this one?
Well, we're getting questions from people. Which one is going to be next?
I'll go over the gist of the plugin challenge, but I don't want to go into the details of it.
Alrighty, I'm not seeing any questions on Smorgas board yet. Let's give it a little bit longer before we dive into the plugin challenge. Seeing no questions, let's dive into plugin.
Sure. I don't actually have the file here, but basically plugin was a ZBrush Z-script. ZBrush is a 3D modeling application commonly used in the film industry for sculpting organic objects. It has a scripting language, ZScript. When you load scripts, which are in text file format, it also creates a ZSC file, which is a... R2 ain't gonna help with this one. I guess maybe it will help with this one, as long as we only see the hex. Yeah, so you can see at the top it's a ZBrush file, copyright Pixelogic Inc. You can sort of go through this, and I'm gonna actually use a different tool to show it. Probably the easiest way to analyze this is to get ZBrush and try feeding in other text files into the ZScript loader and seeing what the ZSC output files are. If you were to do this, then you would find that the start of all the files is basically identical, and all the meat of the script is down here under SRBZ. But this doesn't make a whole lot of sense here, because we have like ... 7.6 exclamation .jj. So what's this? The script is encoded in a particular way. If you feed in enough inputs, you can probably figure out the way it's encoded, and you can decode this. That is one way you could potentially solve this. I imagine there are other solutions. For example, attaching a debugger to the ZBrush process. I didn't do this, so I'm not sure how you would do this, but I am sure there's other ways you could go about it as well. Once you have done that, you would get a file that would look sort of like this. Give me a moment to grab this file. So, ooh, it dropped at the very start of that. Let me try that one more time. Okay, so we start by defining two variables. There's a button called check flag. If you were to load this script, it would add a new button into the ZBrush interface that says check flag. If you were to push the button, it would ask, what is the flag? And provide a text box. And you could then enter something, and you would either get wrong flag or correct flag. We start by doing something with the length of the flag, and then we start checking the ASCII values of each character of the flag. So at this point, it's pretty straightforward, because you can sort of just grab out all these ASCII values, convert them to characters, and concatenate them, and put that in, and it will say that's correct. So really, the challenge here is getting at this text representation from the compiled format, which is not straightforward, because this is not a well-known file format. So this is sort of like understanding how underdocumented formats store information. I am not sure I want to answer any questions about this one. So if we have next presenter, then we can go with that.
All right, thank you very much, Vanilla, for all three of those challenges. Does anyone have any questions about the things that he talked about previously, or about anything that we've talked about during the entirety of the night? Otherwise, we're going to move on. Try to just did a bunch of chat requests and a bunch of just people who wanted to talk about their things. We can do Pranav if you'd like, or we can.
Pranav has volunteered.
All right, Pranav has volunteered.
For which challenge? Constructive criticism?
The
yeah,
bot
and
being
also
constructive
auction
criticism.
bot.
Yeah.
Yeah, I can talk about both while I'm here.
And then Tayagunshi, we are going to do tablet afterwards. White Hood Hacker is going to cover that. Pranav, if you want to introduce yourself, go ahead.
Yeah, sure. So my name is Pranav Goyal. I'm a senior here at UIUC studying electrical engineering. I actually found out about UIUC SIGPwny from like some of the people I met through CTFs, although I'm not the greatest at CTFs, so that's a different topic. So I'll go over constructive criticism first because I think some people asked earlier. Thomas, I sent you the files in.
Can you get the link? We can probably W
pinned.
get them.
It's
Okay.
pinned.
Can you get through Mega and Z via wget?
I have no idea.
Let's
You can
find
try.
out. No.
It seems like a no. Might need to just explain. I would maybe recommend opening the solve script and just talking over the solve script.
Sure. I combined my solve script should be in the repo, so maybe.
Okay. Do you want to do that? You're in control.
I don't have Tmux, I think, open, so.
Does anyone? What was it? Misk?
Yeah, it was MISC. So, while he's doing that, I can sort of explain what it was. So you had the SoundCloud that had a bunch of the lo-fi music, which I got from the Lo-Fi Girl 24/7 stream. They have it free to use. They give permission and stuff. So I decided to use that. And I also provided the WAV files that were compressed in a zip file for you to download if you didn't have that. The script is very simple, or the whole idea is very simple. There's some interference happening within other channels. And to sort of notice like something's weird, you look through and you'll see there's 3 channels instead of 2. Typically there's 2 channels, one for left ear, one for right ear. And sometimes on SoundCloud, your headphones might not pick up some of this because of the way the waveforms are structured. So if you look through, you can mute certain channels, and you'll hear that interference is happening. So once you know that, it doesn't take too long, hopefully, to figure out which 2 of the channels are the ones that are important, that have the secret message encoded. So my script here, all it really does is it pulls in the file, splits the channels into separate tracks, and then overlays them. So all the constructive interference and destructive interference happens, and it cancels out. And if you look at the waveform at this point, it's pretty easy to see that the ones that are making audio and the ones that are cut out are like 1s and 0s. So you can look through that, and each thing is based the same amount. So you can make a script that extracts the 1s and 0s across all 20 tracks, except for the last one, since I couldn't fit in a number of characters evenly, so you'd have to run it again for the last one. And then you end up with the flag. That's it in a nutshell. If anyone has questions about how I set this up, where I found it, or just in general about the challenge, feel free to ask in chat.
All right, and we'll wait about a minute there. Does anyone have any other challenges that they would like us to cover? Feel free to, again, put it in chat or put it in stream Q&A.
Yeah. It doesn't seem like anyone has any questions, so I think I'll just move on. And
let's do it.
the next, the next stuff is.
Do you want me to bring up the
auction
bot?
Yeah, sure.
Okay. Give me a minute. Let me collapse all my discords.
It should be running right. Oh, I can run it right now. Hold on.
Yeah, no, you're all good.
Yeah, it's running.
One second. Let me see if I can pop out this chat. No, I don't think I can. Okay. Someone check. We're all good. Yeah. All right. What am I doing?
Right. So, if you do /help, you should get like all the general info of how the bot works. But the idea was that instead of just grinding it through normal ways, which might take a while, you can exploit some very specific bugs of sort, or the way it's written. One of it is when you're bidding for a bunch of stuff, normally they say like, oh, you can't bid more than what you have, but it doesn't stop you from bidding what you have against multiple options, and you can win multiple bids that way. You'll go into the negatives, but overall you'll net a profit. So it's a really quick way to get a bunch of stuff and shoot your amount up. Another thing was that collectibles was totally broken, and if you just bought a bunch of collectibles, Clout was a very common one people bought. You can just use that and get a ton of money that way. I also added parts that creates a set, and if you buy the parts individually, and then assemble them, the set is worth a lot more than the other parts you have, so you can earn a lot that way. So that was another one, and then I think the last main one that I thought of was you can use private auctions if you have teams to sort of split up what you're buying and sell things for cheap, and then eventually combine all the flags to redeem. Those are the main ones. One person, SIGPwny, broke it because I had written the code kind of bad. So I did like 50,000 interactions with the database and then just broke it. So I had to restart it a couple times. But other than that, I think people liked it. I would love to hear what your opinions were, or if you have any questions about that.
All right. Thank you very much, Pranav. All right, we're going to move on to White Hood Hacker whenever you are ready. We're going to do tablet. Okay, never mind. We're going to... All right, we got a request for industrial Pwnvolution. So that was mine.
That will happen. White Hat Hacker is just working. Getting some set up for the purpose of explaining it.
Yep. So that's good. So we'll cover industrialization. So, all right. So we've got the whole. So let's run. So welcome to the Buff Factory, where we make and fix buffers. We haven't exactly figured out what the rules are, but here are some right and wrong examples. So we've got curly braces, cheeseburger, and then curly braces. And then less than pizza, greater than. And then parentheses, fries, and then parentheses, sodas. And that's going to go to cheeseburger, to then pizza, sodas, and stuff. So the actual rules here, I'll explain the rules. I can actually just open source. So the actual rules here are that there's canaries, there's change buffers, and then there's set buffers. So how the canary works is that well, it's just a canary. You want to make sure that the content inside the canary is not changed. The change buffers, let's go right here. So the canary, it's a canary, and you just want to make sure it's not changed. The change buffer is you want to make sure that it changes or is different from the original. And then the set buffer, which was weirdly hard to get working, is you want to set the first thing in the parentheses to whatever the very next thing is. So they always come in pairs, and you want to set the thing at position 0 to whatever was at position 1, etc., etc. And you'd have to do it, I believe we turned it down in the end to 100 times. I started this at 100,000, and then we realized that if we did it 100,000 times, our GCP expense would be through the roof. So we didn't do that. And then for like a solution script, we can go. So for the solution script, I did, you can receive until the phrase times, and then receive the line. Split it. You can split it by parentheses to get the sets of content for what goes where. And then if to replace all the sets, you can replace everything in sets with sets at I+1. And do that once. This is sometimes buggy, so if it usually works though if it runs 100 times. Then for changes, you can split. You can split by brackets. And then just make sure that it's all A's or all B's if for some reason the thing inside the split is all A's. This wasn't a problem if you ran it 10 times, but because I was running it 100,000 times at the start, it turned out to be a problem. And then lastly, with the canaries, you just didn't do anything, so there was no need to actually touch them. And then you just print the line, print the response, and then send the response. And I can do that now. And it just goes back and forth and back and forth. And it's spamming it. And there it is. UIUCTF, I'll have you know this challenge was unnecessarily difficult to get working. So, does anyone have any questions about that one? All right, I think we're going to move on to whoever is next. I'm taking a look. All right, White Hood Hacker, whenever you are ready, you can unmute.
All right, hello everyone. Can you hear me fine?
Yep. Do you want to introduce yourself?
Yeah. My name's Min. I am an incoming freshman at UIUC. And this is actually the first time I've ever organized or been part of a CTF challenge in terms of development. So this was a great first-time experience for me. And I'd like to thank everyone else for kind of helping pull me through it.
Hey, you did an awesome job. We didn't pull you through anything.
Thank you. Let me connect to the Tmux because I did not get that ready.
Tmux A-T Pwny.
Yeah, I got it. All right. So I did a few forensics challenges. Right now I'm going to be going over tablet. The other challenges I did were Super Hot and 2B2T. I don't want to go into those yet because I want to see what other write-ups people have made, because I know there are some really interesting ones. So I'll go over tablet. But basically the scenario is we have an archive file, and the archive file contains a full file system. Not really full file system, but a very carefully selected physical file system extraction. So Now, you don't. Now to start with the challenge, you could just kind of poke around in the file system. So let me hit ls. So you can. Sorry, let me get rid of this. This is not part of the challenge. So once you extract the tablet.tar.gz file, you'll see a private folder and then a var folder. So this is just kind of basic iOS kind of directory structure. I highly recommend that before you kind of dive into like just jumping into the file system, you read some articles online about the iOS file system, because it's slightly different from like typical Unix-based systems. It's very similar to macOS. I have put a link to a great article in the Twitch chat, and if somebody could copy that over to Discord as well, that would be great. But basically, the objective is to kind of just dig around, figure out what's installed, if there's any sensitive information you could find. For the first Tablet 1 challenge, apparently that you find out that the user has been uploading data to a server. So this challenge basically had a SSH app that was installed on the iPad, and the iPad contained the SSH credentials to connect to the server, and do upload files or whatever it is you need to do. I know a lot. I really like this challenge because I know a lot of people do manage their own servers on their phone. So oftentimes they'll save their credentials just on the device because they don't want to, spend time entering their password every single time. So now you could go and just like search through the file system and then eventually discover it. But there is a great tool called ILEAPP, which is some sort of parser of iOS file systems. I'll cd into that repo, and then you can run a command that will extract it. It'll parse the archive, and it's something like -t. The type will be file system, since you're dealing with the raw file system, and then you can output to a directory. But I've already generated a report, so we don't need to wait for that. And I will use links to just open one of these folders, one of these files. So, for example, app snapshots, it will show you like different apps that were installed on the system. But you could just kind of go through all this. There's a lot of tools out there that will help with iOS forensics. I know a lot of tools out there are paid, and like if you ever think about like forensics, real forensics tools, you have to pay like thousands of dollars for them. But this is a free tool. It's open source on GitHub, and you can see a lot of information just from this. But eventually, you would find information about an SSH app, which is promising, and sorry. So the var mobile containers folder, and we go to data applications. So this folder contains a lot of UUIDs, and these UUIDs are specific for apps. And they're all kind of in these sandbox containers, so that way apps can't access other information from other apps. And the UUIDs are generated on install time, so you don't really know which app is which. You could just kind of search recursively for common strings, or you could use the tool that I mentioned earlier. It will turn those all into normal app names. But in this case, the SSH app was installed under UUID. That UIUD, I don't know. I don't really know. And then you could just do a little bit poking around, and then you eventually find a database file for WebSSH, and you could just use any standard SQLite database viewer, and then view the tables, and then from there you could kind of query any interesting columns. Sorry, I forgot semicolon. And here you can see, well, you can't see this because it's kind of cut off, but you'll find the SSH private key for a server. And you'll also see find other information such as the host information. So in this case, the host was red.shell.uiuc.tf, the port number, the decryption password, and all the juicy information we need to connect to the server. So I will quit that. And actually, I still need to extract that because I don't have the private key saved just yet. And I have to set values. Wait, what is that? Oh wait, I spelled it wrong. I did not include the file name. That's why. All right, you know what? Here, this is what I'm going to do. I'm just going to copy and paste a key from my own machine. So we'll just make a IDRSA file. Let me quickly grab this. And then we can connect using the credentials we found. So the port number was 42069, haha, funny. Used a private key, and then the username was red, and the host name was red@shell.uiuc.tf. And so once we connect, we can just accept that. Whoops, I forgot to make sure you secure your private keys. Right, and now it asks us for a passphrase. And if you weren't paying very close attention, the decrypt password was also in the data there. It's 8 asterisks, so that's kind of a bit of a troll there for those of you that I spoke to in support tickets and figured it out eventually. Oops, I mistyped that. And then we get this error message saying this service allows SFTP connections only. Okay, so no big deal. We can just use SFTP-P 42069. So same deal. And boom, we're connected via SFTP. And we do an ls, and we don't see anything. And our current working directory is /home/red. We can see that we have access to the full root of the file system. But it's kind of hard to do any real kind of searching for files here because you're limited to the SFTP environment. You don't have, you can't execute any SSH commands or anything like that. So the easiest way to do this is to figure out that there's hidden files, or just kind of work on the logic that, hey, they must have executed commands at some point, so you can just get that bash history. So let me disconnect from that. And if you cat bash history, you will find a command where they move server exfiltrated to server triple dot, which will make the directory hidden on an SFTP. So let's go to SFTP. Let's reconnect via SFTP. Sorry. And then if we go to the server directory and we run an ls, we see there's no directory listing, but that's because it's a triple dot directory. So we'll cd instead. And now if we do an ls, we can see we get a file important data.jpg. We can get that. And if you open the JPEG file, it will give you the flag. So that was tablet 1. It was very interesting because it wasn't just completely on-device forensics. You also had to connect to an external server to finish that. So are there any questions for tablet 1 before I move on to tablet 2? Seeing any comments about the asterisk? All right. Okay, so glad people enjoyed that. And then tablet 2 was actually the first challenge I made for the tablet series. I focused on like making on-device forensics first before I thought of the SSH connection. So in tablet 2's challenge description, you're given a hint that Red has been in contact with another person. So there's a number of different apps that an iPad could have to communicate. One is being the iMessage app, and if you it's one of the easiest files to find. So if you go to cd private var, I think it's mobile library, no documents. Oh wait, sorry, I need to go into extracted private var mobile library. Yeah. This is a very easy folder to find when you're just kind of going through the file system. There's an SMS folder, and it's just a simple there's just a simple sms.db file in there. The intended communication platform was Discord, but I also added kind of a communication in iMessage because I knew that a lot of people will expect there to be something within text messages. So I kind of put that as a hint. And then it would eventually redirect you to the right place, which is Discord. So you can select all the chat messages, or sorry, it was just message. Seccomp. And you just gotta get a simple conversation where it's asking, hey, what's your Discord tag? He gives your Discord tag, and kind of just the only thing you use text messages for is to get your Discord tag, right? Nobody actually uses iMessage. Just a joke. But from there you can figure out that, hey, I need to check Discord messages if you didn't know that already. And then using the same kind of tactic from earlier, you can discover the directory of the Discord UID folder, which was data application. I need to pull this. I can also just grep for Discord. Find dash type dash type fd dash in name Discord. So this is an example of how you can just kind of use just simple shell commands to find what you're looking for. So we can very clearly see that the UID we're looking for is that. Oh my gosh, I don't want to run the CDC command. Make sure to wear a mask. And then we can just kind of poke around here a little bit more, exactly like before. And eventually we will find a cache directory. And inside the Discord folder, we can find another cache.db file. In case you guys haven't kind of picked on it by now, iOS stores a lot of this information in SQLite databases. So this is a very handy tool to have if you didn't have it. And then you can do dot tables. There's 3 columns, but the only one you really need, tables, the only one you really need is the receiver data. You can check each of them. But this will give you all your juicy information. And so we can see here there's just a huge blob of JSON. And this JSON is actually your Discord chat messages. That's how Discord sends all its information. So you could throw this into like a JSON parser or however you want to view it. But the conversation went a little something like, hey, white is on to me, and then blue, which is who red was contacting, will tell red, you need to make sure this next plan goes correctly. I sent you an encrypted note. The password is Susibaka in a very funny spelling. It's also enclosed in double pipes, which is used in Discord for spoilers. So if you were trying to use that as a password, you needed to remove the double pipes because that is not part of the password that is used by Discord to hide information visually.
I just want to say real quick, I didn't look into this challenge before you submitted it. Like, people had tested it, but I hadn't looked into it. This is awesome.
Yeah, thanks. Also, in this same, I don't think it shows here, but a little bit above all this JSON, it doesn't show in the output, but there is a Discord token. I don't know if you guys tried to use that. I already was expecting that the Discord token would get leaked, so I changed the password beforehand. But I actually had that as a tablet 3 challenge. Basically just kind of messing around with Discord. But kind of had to compress all the other challenges into just kind of one. So I combined the encrypted notes and the Discord challenges into one. And I think it turned out pretty well. So yeah. So you get the password Susibaka. You find out there's an encrypted note, and now you just need to find the encrypted note. And now normally you kind of think like, oh, it's maybe a PDF file, maybe they sent it somewhere. But if you think about it, it's an iPad. Where are your notes stored? So you figure out it's stored in the Notes app. And if you do a little bit of research online, the Notes app also uses a database, which is called notestore.db. However, this database is compressed, and also we're dealing with an encrypted note. So it's kind of a lot of proprietary or not really proprietary, but not very easy to look at data. We can't just use SQLite 3 like earlier. So what we need to do is, well, first we need to locate the notes directory. Eventually you find out that if you just do a little bit of searching for that file name, notes store, I believe it is, .sqlite. I think it might also be .db. Or maybe I think I have an extra S in there. Just trying all of them right now. There we go. So we find the directory where that file is. So I will demonstrate right now. If I try to open this with SQLite 3, and try to do like .tables, we can see things. We can see some tables here, but if you try to view it all, it's just going to be a bunch of blob data. So it's not very friendly to look at. Luckily, there is a very handy tool, if you did a little bit of research, that will parse all this information for you. Let me find that real quickly. It is Apple Cloud Notes Parser by 3 Planet Software. So let me clone that real quickly. And this is a Ruby script. Oh no, you guys are going to have to see me struggle to install Ruby. But I need to read me. I'm sorry, guys. I should have prepared for this.
Doing awesome.
There's an installation command. Yeah, bundle install. I'm not very familiar with Ruby, so just I need to install it. Blazing fast, that is. I need to get Ruby bundler. Alrighty, so, oh my gosh. Oh yeah, so this was a thing. I couldn't get this working on Ubuntu. I remember this now. I couldn't get this working on Ubuntu. There was like a bunch of weird dependency issues. But I did get it working on Kali. But basically, you would run the program, decrypt the database with the password that you provide, and then you would get the flag. Let me quickly grab that. Because the notes, then the contents of the notes are kind of funny as well. Just want to show that real quickly. Let's see, outputs. Oh, I have a folder here. Give me just a quick moment. And yeah, so the flag you would find out after you decrypt it is just there, UIUCTF when the imposters are self. This is an old backup, sorry. But yeah. So that's all for tablet. Hopefully you guys enjoyed. Sorry if I took a little long there.
No, you did great. That was awesome. And it's really informative, and I learned a lot. Thank you. I'm sure people on stream learned a bunch too.
Thank you, WHH. Shall we take a look at the en passant one next? Pawnfish.
Someone just exited out of... So, what are we doing? Pawnfish?
Yeah. Michael, are you attached to the window? Yeah, it looks like you are. Cool. Okay, so the author is currently in a noisy place, which means that they cannot explain the challenge, which means that I am learning how to solve this challenge.
Where is Pawnfish, Rev?
We have an explanation. Yeah, Michael, are you controlling things? Feel free to reply.
No, I actually cannot SSH into them.
Let's debug that.
Alright, how should I do this?
Use SSH-V to see which key it's trying.
Oh, wait a second. I think I found out what happened. Right, there we go. Yeah, I'm in.
Cool, great. Do a tmux a-t pony.
And then just type some stuff when you're in.
Okay, let's see.
I'm gonna mute myself.
sorry, tmux a dash
P,
b.
and then
And
Pwny,
then
PNWY.
Like pwny.
tmux a dash t. T is in tiger.
AT. Success? That looks like success. Yeah, great. Awesome.
Awesome.
Alrighty, can you go ahead and, we're in the right tier. Can you open up the child.c and we'll start taking a look? Pete gave us an explanation.
Right.
Challenge.
Oh,
The challenge directory, yeah.
and
Child.c.
oh, dang.
I'm
do you
sorry.
guys only run out of Vim?
Go ahead and install it.
Oh, sure. Yeah.
Twitch plays install Emacs.
Cool. Okay, so there we go.
So we have, here's the source code, which was distributed with the challenge. Yes, I think so. I'm not sure. I think so. Yeah, it was. So the challenge is named Pawnfish, which is a hint to that it's an en passant related to en passant, which is a particular chess move that involves moving pawns in order to capture pieces. If we go to the check pawn valid function,
Down here.
then on line 225, there is a bug, which is an incorrect implementation of en passant, which allows you to capture any enemy piece with a pawn. You're only supposed to be able to en passant with just a pawn, so it's a bug in the implementation of the chess engine. The line is 225, so 12 lower than your current one, I think.
Oh,
Huh, interesting. So it looks like you have to read and understand the C code. Cool. This would definitely take me a while to understand it. So that's the bug, is that there's no check to make sure that it's a pawn for the en passant valid, for the check pawn valid function, which means that you can capture any piece, even though en passant is only supposed to allow you to capture other pawns as a pawn. So the second half is that the scoring system has an integer underflow on line 546. Michael, if you would kindly take us there.
would you tell me which? Oh wait, line 546. Right?
If you look at the bottom middle of the screen, you can see an L243 currently. It's next to the git main. I think that's the current line number. I am not an Emacs user.
Okay, you're saying line which?
546.
546. Cool.
So we have a signed character, which is interesting. That's for the number of wins.
Wait, 546, right? Yeah, we're on 5.
Yeah, that's the right line. So this line has a bug. This should probably be unsigned. I'm guessing that there's not a bounds check on it. There is a hint at the end of the file, if you can take us to the bottom. You didn't win the 100th game. So this is a hint that there must be some way to get to 100 games non-intentionally. Cool. So that's a very quick overview of the bugs. Basically, it's a C program implementing chess. There's one chess level bug, which is the en passant is possible to capture other pieces. And there's a C level bug, which is that the wins counter is signed, which means that there's an integer underflow, which means that we can get the wins count much higher than it should be. Okay. Michael, could you possibly increase your shell size?
Oh,
Thank you very much. All right, let's switch to a different file. In the health check, there is a file, the directory health check. There's a file called healthcheck.py. Could you kindly open that? What is
health check?
healthcheck.py? Yeah. So this is our solution script. Huh, this is cool. Import stockfish. What is stockfish? Does anyone know?
I do. Stockfish is a very low, not fidelity, or maybe kind of fidelity. It's a low fidelity chess AI.
Oh, cool. Implemented with a neural net. That's right. And so we can see at the bottom of the file, there's a proc.send line, which appears to have a couple of like chess commands. So we've got, that looks like chess syntax to me. So it looks like our solve script has us submitting a sequence of moves that puts the board into a particular state. And let's see, reading the solution from a different monitor, Pete told me that the first couple of moves causes a bunch of loses that causes the integer win count to underflow. I'm guessing that if you lose, it must decrement or something. And that will cause you to decrement and get to 99 wins. And then the last set of inputs is an hard-coded en passant move. And then we run stockfish against itself, and that gives us the flag. Cool. So I guess very intense chess challenge that involves breaking both the C program with an integer underflow and also chess. Pete, is there anything else that I should mention before we move on? All right, cool. That's it. Any questions from Twitch chat? Any questions from stream Q&A? Taking a peek. Any other challenges that anyone would like to see next?
Otherwise, if no one has any other challenges, we can head back to the schedule for challenge orders.
Yeah, that sounds good. What's the next one on the schedule?
We skipped Pwn Warmup and did Auction Bot and Constructive Criticism. We could go back to Pwn Warmup. Yeah. I can do that super quick.
Yeah, sounds good. Thank you, Michael, for the help. It looks like Thomas is going to do Pwn Warmup next.
Challenges, Pwn Warmup. All right. All right, so let's start by R2ing the challenge. No. Cool. So we'll find... So right away, there's a give flag function, which most likely means that we want to find a way to trigger this function. As you can see, because there's source here, you can see the comments. And then there's a vulnerable function. So let's define this. Oh, no. Oh, my R2's rusty. Okay, I can't remember how to do it graphically, but anyway, we've got a vulnerable function right here, and then we've got main. So all main does is it sets vulnerable buffer, and then it sets vbuff, and then it calls vulnerable. So inside vulnerable, we've got push edx, and we're going to we're pushing to the stack, and then we're just going to call gets, and that's it. So let's look at source. So we've got give flag right here, and then we've got vulnerable. All that vulnerable is an 8-character buffer, and then gets a gets. And for those who are unfamiliar, gets is extremely insecure because it just allows for arbitrarily long input. So if we do challenge, I can't execute it because I am on a 64-bit Windows system. So let's go check dot solve.py. So here's the solution script. You can remote into the address, and then you receive until the flag the equals for your input. Then you get the next line because that's the address of the flag, and you turn it into an integer. Then you turn that back into an address, and then you just send that back at the server as many times as you can. And what happens there, in simplest terms, is bringing up MS Paint. So if this is the stack, and this is where we are on the stack, what we want to do is overwrite this value right here, just under the stack, separated by a value that we don't really care about. And we are right here. And in between there, there's an 8-character buffer, but we're going to write this way. So we write through that 8-character buffer, we write through whatever this is, and then we overwrite this address. And what that address is it's the program return address. And when it returns, it says, hey, I'm done executing a function. Where do I go now that I'm done? So it's going to return, and because it was printing out the flag address, or the address for the function give flag, it's going to jump to our flag function. So that's what's going on in that challenge. Anyone have any other questions about the Pwn Warmup? Otherwise...
While we're waiting for questions to trickle in, it looks like Spamakin is going to do RE Baby next.
Sounds good. Let me get that set up.
Could you tmux ls?
No, I am attached. What the heck?
I think that means that somebody else is attached. You can just do tmux A if there's only one.
Hello. Okay.
All right, Spamakin, ready to go?
Yep, okay. Is my volume okay?
Yep.
Perfect. Hi, my name is Anakin. I'll be a sophomore and this coming fall, and I just joined the club and got into security in the past couple months, so so far has been really cool. And yeah, big fan of the event so far. It's been great helping run it. So the challenges I wrote were capture the flag, and then a baby RE challenge, and I'll be going over the latter of those two currently. So, just a quick demonstration of the challenge, though I'm sure most of you saw it. If I just do, hello. That's okay, cool. So this currently takes in some inputs, blah blah blah, to ask me for the flag. And there's just a little Easter egg. If I type in cool, just simple enough. Challenge is input the correct flag, okay? And the goal of the challenge was just to get new people to get into reverse engineering and open up the program. So, look at the source code for this program. I forget what I called it. Okay. So what do we see here? We have a function called generate, and further down, we also have this defined size, list size, which we can see in generate. Further down, we have a good old rot function and a good old shift function. So let's just quickly go over what these do. I'll start with rot and shift since they're probably the most applicable. So rot is a good old cipher. You guys may have heard of rot 13, a very common intro cipher. And all it does is if you map out the letters in the alphabet A through Z with an index 0 through 25, rot by an integer I will just move that letter along the list by I spaces. So if we have letter A and we do rot 5, A would move up 5 spots, so B, C, D, E, and then to F. Simple, and that's all that's happening in rot, and it just does that along the entire string. shift just takes characters at the end and moves them to the beginning. So if we have a string ABCD and we call shift on ABCD and we shift it by 2, the result will be CDAB. So we've shifted the start of the string by 2 characters. So now let's just go to main. So I generate an input from whatever the user takes in. Then from I is equal to 0 to list size, I call rot and shift in succession, but the values I'm calling with these functions are generated by this array P. And what does P do? Well, let's go up. P is the output of generate. And some of you may recognize this code if you've done Project Euler problems, which are like LeetCode, but more they're like LeetCode, but more math oriented. This is a prime generating sieve. And all this does is we start a list with 2, then starting from 3 on and up, we generate the primes until we have a size of primes of list size. So this generates the primes from 2 all the way up to the 1337th prime. And I'm using that to call my functions and scramble the output. And you can see, so one quick example is flag words with underscores and letters. When that gets put in, we saw earlier, generates the output. The second output, and we print very funny, but this flag right here, that you can see on, I guess by line number 8, that is the current flag that we were trying to find, but that's the scrambled version. So how can we solve this? So I guess the brute force method would be to go through and take this input and undo every single one of these rots and shifts one by one through all the primes. And while you could do this, there's in fact a much cleaner way of doing this. So if I do, what do I call it? Let's look at the solution script. All right, so again, same functions. And we can see that this decrypts. Okay, so first what I do is I sum up the total primes. And then let's go through decryption. I decrypted both the actual flag and then the very funny thing. But the methodology is the exact same. So this takes advantage of 2 facts. Rot of 0, so not doing anything, is the exact same as rot 26. And then furthermore, shifting by 0 is the exact same as shifting by the length of the flag. So because of this, rather than doing whatever 1337 times 2 steps to decrypt, you can do this in 2 steps. And so, you can see that what happens is, I propose to consider the question, can machines think? Which is a reference to Alan Turing's paper. That is the flag. And if I run the solution script, that goes through. And this will all be released eventually so that you can go through the code yourself.
Yep.
You see the total sum of the primes is this, and this is how many times rot is being called and shift is being called in the enciphering. And then we can see the unscrambled flags for the actual flag, and then just a little Easter egg flag where it's the underscores and letters. And that's the methodology between solving my baby RE challenge.
Awesome. Thank you so much. Anyone have any questions?
Looks like we're good for Ropfuscated next.
All right, sounds good. We're going to cover the really cursed one. Nate, whenever you're ready, feel free, introduce yourself.
Hey everyone, can everyone hear me all right?
Good.
Cool. All right, what's up guys, I'm Nathan. I'm the one who wrote Ropfuscated, along with my friend Victor and Pete, who also happen to go to UIUC. I'm going to be a junior this semester. So we developed this challenge, first of all because we wanted to see something extremely cursed, and second of all because I woke up one time with this idea that what if we could compile C to a ROP chain? And so let me preface this by saying, if anyone's not familiar with the ROP chain, it's a exploit strategy when working with a binary where the stack is not executable. You could just jump around the various parts of the text segment. I encourage you to look into it. My explanation is going to require somewhat of prerequisite knowledge on that. But if not, go ahead and read up on ROP chains. So what I did to develop this challenge, well, first let me say what the challenge is. I guess we could have showed the challenge itself, but that's alright. If you
I can bring it up.
If you want to go to the directory and execute the binary, you can after you unzip it. But until that happens, I'll continue to talk about it. Yeah, so the entirety of the program itself is an entire ROP chain. I think it's about 4 megabytes of addresses, which is the ROP chain. It's literally just a meme. Yeah, feel free to unzip that and then go ahead and just /Ropfuscated. So the best thing about this, hopefully this doesn't mess up the teamwork session because I mean it does some crazy stuff with terminal control characters. We wanted to make an RE-chal which does not require like flag checking, because flag checking is a very popular RE strategy because it's very pure, right? You just reverse the encryption function. And so we came up with this idea where we're going to have like an Android style lock screen, which I thought was hilarious. And so on its own it would be a good RE-chal to try to figure out which pattern gives you the flag. And then the fact that the entirety of the thing was a 4 megabyte ROP chain was just comedic to me. And then and so how this was made, we'll talk a little bit about that. So it only got one solve, but how it was made is that there's a project called ELVM, which is a C compiler which compiles C to a minimal set of instructions like move, add, sub, and some conditionals. And we were able to use symbolic execution through Anger and a project called Angrop to search for gadgets which we could be useful in a given binary, and then we could map those gadgets to ELVM instructions and combine them. He's using like many layers of abstraction here. And so we were able to produce a very, very cursed binary. I encourage you guys to all open it up in Ghidra and look at what exactly happens here. But this entire program here, this little game, Android lock screen that we got going on here, is entirely driven by a ROP chain. And I'd like to finish off by saying that there is some practical uses, but very, very, very little practical uses to this program, or this compiler, I mean. We went into this hoping to come up with a generic C compiler to a ROP chain for any libc, because it may be useful when we're developing exploits. We can just say, syscall this, write this value here. It's a quite easy thing to do. And there's projects which do that, but just not with C, right? But unfortunately, we had to rush it done, and so we weren't able to make it general, but we were able to produce this crazy chow here.
What's the proper here? Not what's the solution, because that would take us hours.
Do you want to show the solution?
Yeah, what is? I don't remember.
Yeah, sure. So it's we may as well just show the solution here for anyone who's interested. Write-ups are coming, hopefully.
Hopefully, the one team that solved this, we want to hear how you solved it.
Yeah, the flag has changed to start with the top middle, then go to the middle left. So it's changed completely, Thomas. And sorry, yeah. So top middle, middle left, then center, then top middle. Your stream is lagging. I'm sorry, I can't tell which stage we're in here.
Middle, left, center.
Let me just send it in the Twitch chat.
Thank you.
2, then 4, then 5, then 2, then 5, 8, then 7, then 8, then 9, then 8. Okay, I think that's the one. If it's one index starting from the top left and 9 in the bottom right. Yeah. And So
I just read the flag.
yeah, and a funny consequence of this is that technically this is a proof that ROP is string complete, which has been a well-known fact for quite some time, but it's kind of fun. So that was the challenge. I hope I didn't drive any of you insane who are trying to solve it, but it was a blast to make with my friends, so appreciate it.
Right, and somehow the terminal's not broken after all of that. Alright, does anyone have any other next requests? Otherwise, we're going to move on with the... PonyDB is... we covered it earlier. You can watch the VOD when we released that. Or did we not cover PonyDB? I don't remember. Anyone? We did? Okay, cool. So PonyDB we covered earlier, and Yana, I don't know if we're going to cover that because the Chow author is not here at the moment. So let's move back to the schedule, and we've got Ropfuscated chat request. So does anyone in chat... whatever anybody wants to do, we'll take the first thing that someone requests and try to make it happen. So I'll wait about a minute, and if no one responds, we'll move on to the next one. We're gonna cover powerful in a bit. Who made Quarious Transmissions? Was that Boron?
Yeah, that's Boron.
I don't know if Boron is here.
If you want to for that, I could quickly just
Can you?
say RPM. Yeah. So the solution to that was through something called super dense coding. I believe that's what it's called, if I remember correctly.
Oh, he's got a solution file.
Yeah, and so it's a technique to send two classical bits with one qubit. And a way we can do that is just by, also a variant on that super dense coding is by transmitting the actual quantum operations that we do with a shared state. And we updated a hint halfway through the competition that the actual bits that were transferred actually form an image. So then you read this, you decrypt it using super dense coding. Go ahead and look that up on Wikipedia, but also look at XMUS CTF 2019 for almost an identical challenge. And then the solution would be to export that to an image and view the QR code for the flag. Hopefully that helps.
All right. We got SVG. I forget who was SVG. I forget who did SVG. That was Encore. And Encore is not here. So, to that point, any other Pony IDE we're not going to cover because there is still a bounty out for the first solution for Pony IDE. So let's wait on that, and then we might do like another stream sometime later. Last year we said we were going to do that. We're going to actually try that this time. We got Vaudeville. Who did Vaudeville? Eric. I don't think Shell Author's here. I'm sorry. Does anyone want to try and explain Vaudeville? Is there a solution script? Oh, there is. Huh. Here's the, so this is the solution script for Vaudeville. Does anyone who tested this? Are they here? Would they be able to explain it? No, I don't think they're here, unfortunately. All right. Any other challenges? The Python gels? Nate, do you want to do the Python challenges? The Python gels?
Yeah, I'd be happy to do that.
Awesome. Let me get there.
All right, let's do that. All right, Thomas, if you're driving the terminal, I appreciate
Baby
that.
Python or Baby Python fixed?
So let's start with Baby Python fixed.
All right.
So, yeah, so you might have seen these Baby Python fixed, and it's a joke. The names themselves are jokes because the challenges themselves only differ by a single character. So if we go ahead and cat challenge.py or Vimeo, that's cool. Get the syntax highlighting. Let's see about this regex here. So essentially this says it disallows anything in this regex. In other words, you are not allowed any lowercase alphabetical characters or whitespace. And so what this means is that our goal is to produce some input which will give you shell code or not shell code, sorry, code execution or printing the flag that doesn't contain these. And so if you're not familiar with Python, you're probably wondering how is that possible, because Python has a lot of lowercase alphabetical things. And the answer is using Unicode normalization. So what that means is if I give like an italicized A, when Python puts that through exec on line, we see here 1. I think your line ordering is interesting in here. When it says exec input, what it's actually going to do is first normalize those Unicode characters into the ASCII characters. And so it will take that italicized A and it will make that a regular A. And so essentially if we give it italicized exec or a print or whatever, it will get past the regex catch, or and then when we exec it, it will normalize it and then actually do it as intended. And so the solution here is to send some script like readFlag.txt, which is just with Unicode italicized characters or some variant which is normalized to the ASCII. Okay.
All right.
And then we can move on to, we could show a concrete solution in healthcheck.py if we want.
Yeah.
Feel free to vim that so we can see what it might look like.
Nope.
Okay, so I'm assuming we're in healthcheck.py. Oh yeah, stream's just caught up. And it looks like Vim is having a hard time displaying these characters. But what's going on here is that this is actually like bold import here, or italicized import, underscore underscore import underscore underscore, and then it's gonna be OS, and it's gonna be like read or exec or something like that. But that's the idea. Ideally, we have a terminal that supports the Unicode, but that's all right. Okay, let's take a look to Baby Python. And so just how Baby Python fixed disallows lowercase alphabet, Baby Python only allows lowercase alphabet, and that's the joke here. And so as you can see, this challenge differs by only a single character, which is that caret right there before the A. All right, and so the first thing you have to understand is that we can only do whitespace and lowercase alphabet. And so I think Zhuyifei, if you were on here for his stuff earlier, he said a great thought process through this. So, okay, only allowing lowercase. Let's look at the statement. It must be a statement. Which statements only have lowercase? And you will immediately zoom into the, let's see, the like keywords of Python. So that's like the ifs, the for, the def, the int, and all these sort of things. And you're going to encounter the import. And so the import is actually the trick here. It's kind of crazy, but the import is the solution. And so if we have no parentheses, we cannot invoke a function here easily. And we have no equal, we can't assign anything, so we also can't reassign functions which will be executed using equals. But we can reassign the function which will be executed using an import. So at line 3, it's going to execute exit, a function called exit. But if we say import x as exit, then we can reassign what function exit points to, and it will execute that function instead. And so over the course of the competition, I've seen many solutions for this. There are many different imports that you can do that will give you code execution by reassigning exit. I think the smallest and the most efficient is something like from code import interact as exit. And so we'll show you that here in a sec. But what that does is it reassigns the exit function to code.interact, and that function happens to just pop you a Python REPL. And so if we look at the health check, we'll be able to see that. Just wait for stream to catch up. Yep, so from code import interact as exit will just immediately give you a Python REPL, and you can type openflag.read. So those are the techniques there. Pretty fun stuff, very contrived, probably not something you'll see in the real world, but still fun nonetheless. Hope you enjoyed it.
All right. Does anyone have any other challenges? All right, if not, we're gonna go to the schedule, which was chat request catching Al Capone. That was me. So let's do. All right, so if we are to challenge and go here, you can see that a lot of the function, I didn't strip the binary, so it was kind of clear what a lot of the function names were. So init graph, set edge, add edge, remove edge, node values, min distance. So the actual vulnerability here, let's leave this. Cool. So the actual vulnerability here, ignoring all the many a print statement, is we've got input. It takes an input, and you fill the graph, which is on the stack, with the input buffer, and then you name the graph, and then you're also allowed to set where Capwn starts and ends. So that can be any character, U8, uint8. So you then get input buffer, and the input buffer, notice here, is input size. But then with the creation the name buffer, it's name size. So it's a simple buffer overflow, and there's a mem copy here. And the mem copy copies the name address into the input the input buffer's value into the name address, and its name and it copies over name size. But the interesting thing here is that if you look in lines 166 and 7, 165 and 66, the name address is right by the input buffer. So you can overflow the input buffer into the name address to get arbitrary right. From there, what happens is it runs shortest path. The catch al script function runs shortest path, and the short path will find it'll use Dijkstra's algorithm to look at the graph and find the shortest path through the graph, and then it will take the node values. So it'll ignore the node values during actually finding it, but it'll take the node values during calculation, and it'll return it to short path, which is just an array here. And then it prints out, it files it in the filing cabinet at this position, because I didn't want to be too cruel and hide that. So it files it in the filing cabinet at that position. So you overflow, you have arbitrary read, and you overflow to here, and then do the math to get the return address, and then you overwrite to the shortest path buffer, which you have hopefully filled with a shortest path, which's values were shellcode. So that is that, and I can show you the solution script. So the actual solution script here is you just receive until the line, and then here's the shell code, and then here's the shell positions that I had as well. So you just do that, and then you send the shell code, and then when you're done, quick thing to note, for some reason it would overwrite the start and end position, so you had to reset those to make sure everything was okay. That will not run because the path is off, and I can run it. Oh. I had the wrong thing. Or not. I guess it's just going to decide not to work, which is unfortunate. But ultimately, it prints out, you pop a shell, and you get tax evasion is bad. That's how Capwn got caught. All right, so that's that. Next, we are going to talk about powerful.
Okay, hello. My name is Kuilin. I just recently graduated from UIUC. Was a part of SIGPwny for 3 years. And yeah. So powerful is an interesting... Oh, let me connect to the SSH real quick. Powerful is in crypto, even though it's not really crypto. Okay. So powerful is a proof of work challenge. There's nothing underhanded about the Python file. It's just it asks you for a nonce where you append a request and you do the SHA, and then if it has a prefix with a certain number of zeros, then you pass the proof of work. The notable thing when you see this Python file is that the difficulty is set to 64, and 2 to the 64 is a lot of hashes. On a typical GPU can do something in the realm of tens of mega hashes per second. And so if you're running brute force on a typical GPU, this will take like definitely more than 1 million years to get 2 to the 64 hashes. So tossing a lot of compute power is not the solution. So the intended solution is to use the Bitcoin blockchain. So you can tune out for a minute or two if you already know how Bitcoin works. But basically, the blockchain is a distributed way to have a trusted, immutable ledger, which basically means that they want a data store where you can append things to the data store, and then that data store will be permanently changed every time you append something to it. So like you can't append something to it and then later on claim that you didn't append something to it. And it uses this to implement the transaction database of who has bitcoins and who gives what amount of bitcoins to who in order to make transactions immutable, basically, so you can't reverse transactions. So the way to implement this is via the blockchain, which is every 10 minutes, every 10 minutes a new block is created by a miner somewhere, and Bitcoin mining is basically trying to find a nonce that can be appended to the block header in order for the hash of it to have a specific quality, and and we can ensure that the time it takes to create a new block is 10 minutes by dynamically adjusting the difficulty based on how difficult it was to produce the last blocks. So it's sort of reactive in that way. So because any miner can create blocks, and miners are programmed to trust blocks that match the difficulty rule, if an adversary wants to fabricate transactions, they're going to have the hash power to reliably create blocks faster than the average miner, which is when Bitcoin's network gets really huge, a lot of computing power. You basically need to have more computing power than half of the Bitcoin network, which at that point, it's arguable that the computers under your control are legitimately Bitcoin and not everyone else. But that's a more philosophical point. So the criteria that Bitcoin uses to determine whether a block is accepted is that the SHA hash of the block has a certain number of leading zeros, which means if we take the current Bitcoin blockchain, which has many blocks, tens of thousands, I think, of blocks, and most of those blocks are SHA hashes with pre-images that are publicly known that hash to SHA values with many prefix zeros. And if you look at the powerful source code that's on the stream right now, that exactly matches the format that we need for a lot of zeros prefixed. And the request is actually only 2 bytes, which means we can iterate through all of the Bitcoin blocks and construct a lookup table of 65536 entries for hashes that are requested. So yeah, and then we just look up in the lookup table what to respond, and then respond it, and then everything works. The standard way of fixing this problem in actual proof of work setups is to implement a Bloom filter, which is basically a fast way to check and make sure that something that you have submitted is unique. It hasn't been submitted before. So applications of a Bloom filter would be if you have like a website and you want to count the number of unique IP addresses that hit the website, and it's very popular. With a Bloom filter, you can probabilistically calculate this instead of having to store every single IP address. It's the same with proof of work. If someone's DOSing your service, you don't want to have to store every single unique string they toss at you. But using the Bloom filter algorithm, you can, at log complexity, check to make sure a submission to a proof of work problem you have sent out has already been submitted or not. So these Bitcoin blockchain headers, which occur only once every 10 minutes, so that's very infrequent, are going to be submitted once against your Bloom filter, and then that's it. Of course, you could also not use prefixes of zero because you know that Bitcoin uses that as its thing. The best way to implement a Bloom filter for a typical client is to just use Redis. They have this excellent hyperlog log data structure that implements it in a constant amount of memory. Yeah, that was probably a huge unnecessary tangent, but if anyone has any questions.
Checking all the places for questions.
Pedantic note, technically hyperlog logs and Bloom filters are different, but they do the same thing.
All right. If anyone has any other things that we can cover, please reach out to us. Otherwise, I think we're gonna call it just about 10 minutes before we finished. Thank you all so much for coming. This has been a great experience for you all. Look forward to continued communication from us in the in the near future. Just especially for the people who have placed top 15, and write up information and make sure to fill out feedback. We'll let you know when it's up on CTF time, so you can submit write-ups there or give it a rating. That's it. Thank you so much. Have a great night. Thank you again to our sponsors, to Red Lattice, NCC, Leviathan, Ret2 Systems. You were all invaluable. Thank you to the development team. Again, thank you to the people that I called out specifically. And thank you to everyone who played. This was great. I hope you enjoyed this kind of decompression stream of everything that we did. The dev team's going to go sleep now. So, all right. I'm going to end the stream. Have a great one.